What we're going to take a look at today is simplifying radicals, but in order to do that, the first thing I want to do is make sure that you know your perfect squares. So numbers are perfect squares if their factors are a number times itself. So for example, 1 is a perfect square because 1 times 1 gives you 1. And now if we multiply 2 times 2, we get 4. So 4 is a perfect square because 2 times 2 gives you 4, a number times itself. If we multiply 3 times 3, we get 9. So 9 is a perfect square. And if we multiply 4 times 4, we get 16. So 16 is a perfect square. 5 times 5 gives us 25. 6 times 6, 36. 7 times 7, 49. And hopefully you can fill in the rest of the numbers for the perfect squares up to 15. Then we get to x. So I just want to make sure that we talk about x's in case you see them. If we multiply x times x, we get x squared. So x squared is a perfect square. If we multiply x squared times x squared, we get x to the fourth. So x to the fourth is a perfect square. Any of your even exponents will be perfect squares. And now this kind of works, if we think about it as working backwards. If I take the square root of 1, I get 1. If I take the square root of 4, it should be square root of n squared. If I take the square root of 4, I get 2. If I take the square root of 9, I get 3. If I take the square root of 16, I get 4. If I take the square root of 25, I get 5. Square root of 36 is 6. Square root of 49 is 7. And again, you can finish filling in the table. When we get down here, though, the square root of x squared would be x, and the square root of x to the fourth would be x squared. And so what you should see is that when you square something and you square root something, they undo each other. All right, but this is the column that we really care about, our list of perfect squares. We're going to need that moving forward when we try to simplify radicals. But again, make sure that you fill in all the values that are missing from the table. Your table should be complete. The next thing we're going to do is actually look at simplifying radicals. And we're going to start by looking at 2 examples, and I'm going to show you how to simplify them in 2 different ways. The one way that I like is if you actually know your perfect squares. So I'm going to look at 50, and what I want to try to do is find 2 numbers that multiply together to give me 50, but one of them should be a perfect square. And so if I think through my list of perfect squares, one perfect square that will divide into 50 is 25. So I'm going to rewrite this as 25 times 2. So the square root of 50 can be written as the square root of 25 times 2, and I haven't changed the value at all. And now because 25 is a perfect square, I can take the square root of 25, that's going to give me 5. But 2 is not a perfect square, so that has to stay inside the square root. And so 50 simplified becomes 5 times the square root of 2. Now another way to think about it, if you're not good with your perfect squares, we can break this down into prime numbers. So 50 might break up into 5 times 10. All right, and 5 is a prime number, but 10 could be written as 5 times 2. And now I have all prime numbers. Now, the only way that I can take something out from underneath my square root is if I have 2 of them. It's a square root, so the only way I can take something out is if I have 2 of them. So I have 2 5s, so I can take a 5 out, but I only have 1 2, so that 2 has to stay underneath. So it doesn't matter to me how you simplify as long as you can come up with a way to simplify. All right, so same thing with 96. With 96, what I want to try to do first is find 2 numbers that multiply to 96. One of them I would like to be a perfect square. So for example, 16 times 6 gives me 96. 16 is a perfect square. The square root of 16 is 4. 6 is not a perfect square, so it has to stay underneath the square root. All right, another way to do this is to kind of start simple. If I start with 96 and I'm not sure what goes in it, I could always try to divide by 2. So I get 2 and 48. 2 is prime, but 48 is not. So 48, I can take a 4 out. And so I'd get 4 and 12. And now 4 I can write as 2 times 2. And 12 would be 6 times 2. And then 6 would break up into 3 times 2. So in the end, if I collect everything, I have a 2, I have another 2, another 2, a 3, another 2, and another 2. All right, so remember all of that is under a square root. So to take stuff out, I need groups of 2. So I have 2 2's there, I have 2 2's there, and inside I'm left with 1 2 and 1 3. So when I simplify that, I get 4 square root 6. So again, either way you're going to get the same answer. It's just for me, this one is faster, but you have to know your perfect squares. This one's going to take a lot more work and a lot more space, but if you can break it down, you can pull out groups of 2. So to me, it doesn't matter. It's whatever's easier for you.